We will now determine the domain of f of g. So here we have this f of g function, which is 5 over x squared plus 2x. First, I'm going to write the denominator expression of f of g in the factor form. So that is, I'm going to put this expression x squared plus 2x in factor form. And so this equals, I can factor x from both terms of x squared and 2x. And when I do that, I get x times of x plus 2. So this is the factor form of the expression x squared plus 2x. So I can rewrite this f of g function as f of g, and this equals 5 over x times of x plus 2. And now to determine the domain of f of g, when we are finding the function f of g, we say that g is the input function. This is the input function to the composite function f of g. And while finding the domain, we have to look for any domain restrictions on the input function, that is on the function g of x. Clearly, the g of x is defined for all real numbers because it's just a simple polynomial function, that is x plus 1. So this is defined for all real numbers. So there are no domain restrictions on g. However, we will also have to look out for any domain restrictions in f of g, considering the input domain restrictions. So the domain restrictions on f of g, which is basically a rational fraction or a rational expression, that is 5 over x times of x plus 2. So when you find domain of this rational expression, we have to look for the denominator equals 0. So let's do that. I put this denominator expression x times of x plus 2 equals 0, and this clearly says that x equal to 0 and x plus 2 equal to 0. So we get x equal to negative 2 and x equal to 0. That is for the two values of x, which is 0 and negative 2, the denominator becomes 0. This denominator is 0 when x equal to 0 and x equal to negative 2. So these are the domain restrictions of the function f of g. And so combining these two domain restrictions, that is the domain restrictions of the input function as well as the domain restrictions of the f of g function, we can write the domain of f of g in interval notation as this is domain of f of g. We have to exclude these two values of x, that is 0 and negative 2. So I can put this as negative infinity to negative 2, and then union negative 2 to 0, and then union 0 to infinity. So this is the domain of the function f of g.